My last tutorial is going to be on solving trig equations using the addition formulas and also the double angle formulas that we've been looking at. So in this question here, you've got to solve 4 sine 2x equals 2 sine x, and the domain you've got to solve it over is between 0 and 360. Okay, so first of all, you've got to just recognize that if it's got sine 2x, that means you're going to start using the double angle formula. You can rewrite this as 4 times, and sine 2x can be rewritten as 2 sine x cos x. And that is from what we did in a previous tutorial. Sine to alpha is exactly the same as 2 sine alpha cos alpha. So I've rewritten that out, the sine 2x, and I've still got 2 sine x on this side. Now, let's multiply the brackets. So we just do 4 times 2 is going to give you 8 sine x cos x. And now that equals 2 sine x. And when you solve any trig equations like this, it's best to make it equal to 0. So we bring this 2 sine x onto the other side. So we take away 2 sine x. Swap that onto the other side, becomes a minus 2 sine x. Okay, now we're ready to solve this. We can factorize this. We've got a sine x is common there, and also we've got a 2 as a common factor. So we can take out 2 sine x, and we're left with 4 cos x minus 1. Now to solve this, we've got 2 possible ways this can become 0. It can become 0 when 2 sine x equals 0, and also when 4 cos x minus 1 equals 0. Oops, I should have put equals 0 there. So that means the only time you're going to get this 0 is so the only time that the only angle that will give you 0 is when it is going to be 0 degrees, 180 degrees, and also 360 degrees. So x here can be any value from 0 degrees, 180 degrees, and also 360 degrees. And the reason for that is, if you look at a quick sketch of the sine curve. The sine curve starts at 0, it comes up at 90, touches at 180, so that's 360 there, 180 there, and 0 there. So that's the reason why there's 3 possible answers for there. This one over here though is a bit trickier. We've got when you rearrange that, you get cos x is equal to a quarter, which means that x is going to equal the inverse cos of a quarter. And I've not got a calculator on me, which is a little bit annoying. So you have to work out whatever that angle is going to be. Let me just pause it and grab a calculator. Okay, so the inverse cos of a quarter is 75.5 degrees. Now the problem is there's more than one answer here because our domain is between 0 and 360. So you've got to go back to what you're learning back in Unit 1, which is all about cast diagrams. So you draw your cast diagram. Cosine, all, sine, and tangent. This is 0, 90, 180, 270, and then back to 360. Where our associated angle is 75.5 degrees, so that's going to be in this quadrant here. Now we have got a quarter here. That means that our angle has got to be where the cos is positive, and the only 2 places where the cos is positive is in all, and also in this quadrant, in the cosine quadrant. So we put our associated angle into this quadrant. So we've got to work out what the angle is that goes all the way around, right around to there. And there's 2 ways of working it out. We can now do 270 plus whatever that angle is, or you could do 360 minus 75.5 degrees, and that will be your other angle. So the angles for x can be 75.5, and also the other one is going to be 200. Just did that quickly on my calculator. 284.5 degrees. So our final solution, we've got a total of 5 different answers here. Our final solution for that equation is x can be 0, 75.5 degrees, it can be 180 degrees, it can be 284.5 degrees, and also it can be 360 degrees. 5 possible solutions. If you put any of these angles into this, you will end up with this side being the same as this side over here. Right, I was going to show you a harder one though. Okay, here's a harder question. Again, it's using the addition formula to help you solve this. You've got cos 2 alpha plus cos alpha equals 0. And again, you cannot do anything with that until you use one of these formulas. Now again, you've got the cos 2 alpha, you've got a massive range to use here, but the one you want to use here is this one here. And the reason why you use this one is because it has got a cos alpha there. If that was a sin alpha, you would use this one. Okay, so we're going to rewrite the cos 2 alpha as 2 cos squared alpha minus 1 plus cos alpha. So there I've just rewritten cos 2 alpha using the double angle formula. Now this is a quadratic, so I'm going to rewrite it out in the quadratic form. So it's going to have the cos squared alpha first, then the cos alpha, then the minus 1. Now if you have difficulty factorising that, you can make it a little bit simpler. You could just say, right, well let's just pretend that cos alpha there is x, so we're going to have 2x squared plus x minus 1. So that's what we're going to try and factorise. Hopefully this will factorise. So we're going to have 2x there and x there, because 2x times x is 2x squared. We need to have a 1 times a 1, because that will give us 1 there. And now we need a plus x in the middle, so that means we have to 2x times plus 1. Take away 1 times x will give us the plus x in there. Anyway, I'm not going to go, I did that quite quickly, but that's stuff you're learning previously. So here though, we can rearrange this now as 2 cos alpha minus 1 brackets cos alpha plus 1. So we've got 2 possible solutions here again. 2 cos alpha minus 1 equals 0, and cos alpha plus 1 equals 0. I just realised I forgot to tell you what the domain is, so we'll just say the domain for this is between 0 and 360 again. I mean, they could give you domains using radians as well, but let's just pretend this one's between 0 and 360. So here we can rearrange that as cos alpha equals a half, and this one here we can rearrange it as cos alpha equals minus 1. Now let's deal with this one first. So again, the cos graph, the only time it goes down to minus 1 is down here. Dodgy. There we go. So it goes 90, 180, 270, and then 360. So it's at 270, it goes down to minus 1. So that means we know that one possible solution for alpha is going to be at 270 degrees. Over here, again, the associated angle with this is going to be the inverse cos of a half, and that will give you 60 degrees. But again, because the domain is between 0 and 360, we're going to have a few different possibilities here. So there's my cast diagram. 0, 90, 180, and 270. Because this is again a positive a half, it is going to be in the all and the cosine quadrants. That means that we're going to have an angle here, and also we're going to have an angle down here. So our two possible answers there, alpha could be 60 degrees, and also it could be 360 minus 60 is going to be 300 degrees. So our final solution, we've got three possible answers. We've got it when alpha equals 60, alpha equals 300, and also when alpha equals 270 degrees. Okay, so those are the sort of questions you can get asked when you're trying to solve equations, trig equations, using the addition formula and the double angle formula. Hope that helps.